Hi, are you confused about computing the directivity of a short dipole antenna? Then this video is for you. Let's see how to compute the directivity of short dipole antenna. Directivity. Directivity of an antenna means the ability of the antenna to concentrate its radiation in a particular direction. So directivity in terms of effective aperture A is given by T is equal to 4 pi by lambda square A, where A is the effective aperture. What is effective aperture in terms of the power delivered to the antenna and power intensity? Effective aperture is same as it is the ratio of the power delivered to the antenna to the power density of the incident wave. The power received or the power delivered to the load terminals in terms of the RMS voltage induced and radiation resistance is same as V squared by 4 RR, where RR represents the radiation resistance and S is the power density of incident wave. Now, this voltage induced at the antenna terminals can also be related to the electric field of the wave and effective height of the antenna. That is, voltage induced V is equal to EHA, or it's also is equal to electric field into length of the antenna. So let's say the length of the antenna be capital L. You have V square exactly as E square L square divided by 4 RS will make the equation for our effective aperture. Now, what is our aim? We are trying to find out the directivity of a short dipole antenna. Just now, we have got the equation of for effective aperture in terms of electric field, length of the antenna L, radiation resistance RR, and power density of incident wave. So next, we are going to substitute for the radiation resistance and power density of incident wave. Let's see what is the equation for radiation resistance and power density of incident wave. Effective aperture of short dipole. Just before we got the equation of effective aperture in terms of electric field, radiation resistance and power density of incident wave. But what is the radiation resistance of short dipole? The radiation resistance of short dipole RR is equal to 80 pi square L square by lambda square, or you can even notate it as 80 pi square L lambda square, where L suffix lambda is also same as L square by lambda square. First, so this radiation resistance we have to substitute in the equation of our effective aperture. Next, we have the power density of incident wave, that is S is equal to E square by Z0. So right now we know the equation for effective aperture in terms of E, L, RR and S, and we also know the equation for radiation resistance and power density of incident wave. So now let's substitute these equations in our effective aperture. So A is equal to E square L square by 4 RRS. I'm going to substitute one by one. So first let's try to substitute for radiation resistance, and then we will substitute for the power density of electromagnetic wave. So substituting for the radiation resistance, it has AE is equal to E square L square divided by 4 RR into S. So radiation resistance is exactly same as 80 pi square L square by lambda square. That is the radiation resistance of a short dipole antenna. If you don't know how we got this expression for the radiation resistance, then I can help you with another video. And S is the power density of electromagnetic wave. So now let's substitute that. Next, we have E square L square by 4. Radiation resistance we substituted. Next is the power density, that is E square by Z0. Now let's try to simplify our equation with cancelling out the common terms, and we will get electric field will get cancelled, length L squares will get cancelled, and we have lambda square Z0 by 4 into 80 pi square where Z0 is the intrinsic impedance in free space, its value is 120 pi, which is also same as 377 ohms. So simplifying it, 120 by 4 is 30, and we have 30 by 8 as 3 by 8. And that means the effective aperture of a short type is 3 lambda square by 8 pi. Just now we got the effective aperture of a short dipole as 3 lambda square by 8 pi. Now let's use this answer to compute the directivity of a short dipole. That is, T is 4 pi by lambda square A. So 4 pi by lambda square into instead of A. For the short dipole, it is 3 lambda square by 8 pi. So let's simplify. 4 by 8 is half. Pi will get cancelled, lambda square will get cancelled, and we get 3 by 2, that means 1.5. The directivity of a short dipole antenna is exactly same as 1.5. Thank you.